everybody, welcome to Chapter 15, the digestive system and nutrition. All right, so what is the function of your gastrointestinal tract, commonly called your GI tract? This is basically a long tube that goes from mouth to anus. It's going to take in food products that you eat, organic molecules like carbohydrates, proteins, lipids, and nucleic acids, and we're going to have enzymes that will break these food products down into their smallest form so we can absorb them across our gut wall and into our bloodstream and deliver them to our cells so they can function properly. Now, this GI tract is a long hollow tube that has a central portion in it called a lumen, which the food travels in. There will be many accessory glands that will contribute to this GI tract. They will release secretions that will be involved with digestion. We start with the mouth and we work our way down, and we end up all the way leaving as the anus. So let's take a look at all these structures here. We will go over all of these structures individually throughout this lecture. We start in the oral cavity with the mouth. This is where food enters into our mouth here. And teeth in there and tongue in there, they're basically going to push this food together, chew it, break it down, and form it into a bolus of food. It will then enter into our throat region, which the term for our throat is known as the pharynx. We do have salivary glands that contribute saliva to our oral cavity. Now back to the pharynx here. That pharynx will travel down the esophagus, which runs through our thoracic cavity, and then it'll enter into the stomach. All right. The stomach will continue into what's called the small intestines, which will empty into what's called the large intestines, and will empty out. The end of the large intestines is known as the rectum and then the anus. Now we do have some accessory glands that are in here, such as the gallbladder. It's this little, I'm going to clean this up here, your gallbladder, which is this little green sac here, which stores bile. Our liver, which has a ton of functions, such as making bile, emulsifying fats, making bile, which emulsifies fats. It's also going to store a lot of our nutrients, such as proteins, sugars, and fats. And so you can see there by a tube, this green tube, it's connected to your small intestines. We also have an organ that's behind the stomach. It's a little bit translucent. This is the pancreas. And the pancreas is very much involved with some neutralization of stomach acid and providing us digestive enzymes. All right, so let's go ahead and let's talk about all of these structures individually. First, let's start off with your GI tract. Your GI tract is one long tube, and this long tube has a central portion known as the lumen. The lumen is the portion where food would travel in. The first layer that's surrounding the lumen is the mucosa. The mucosa is an epithelium, and it's lined with glands that secrete mucus and other types of digestive products. It also lubricates and protects the GI tract. The next layer would be the submucosa. This is made of connective tissue, which provides nutrients via blood vessels, lymphatic vessels, and nerves to that mucosa. The next layer beyond this is the muscularis layer. This is going to allow a twisting-like effect known as peristalsis, and peristalsis is the movement of food down your GI tract. Then our outermost layer is called the serosa. You may hear a term called adventitia, but most of our GI organs are layered with an outer layer of serosa, which is a connective tissue layer that connects it to surrounding structures. So these 4 layers would be a part of your stomach. They would be a part of your esophagus. They would be a part of your small intestines and your large intestines. Your accessory glands, they do not contain these 4 layers. So these 4 layers are only predominant towards the actual GI tract. All right, so there's many things that happen in the GI tract. We have examples of mechanical digestion and chemical digestion. Mechanical digestion is going to be things like chewing. Another fancy word for chewing that you may hear is called mastication. Chemical digestion, this is going to be the use of digestive enzymes, which is going to break bonds between our large structures like polysaccharides, which are large carbohydrates, and it's going to break them down into monosaccharides. It's going to break down proteins into amino acids. It's going to break down nucleic acids into their individual nucleotide counterparts. It's going to break down lipids, such as triglycerides, into their individual glycerol and free fatty acids. So enzymes, there's various different types of them. Okay, so our main digestive organs from mouth to anus is going to include the mouth, pharynx, which is a fancy word for our throat, esophagus, stomach, small intestine, and then large intestines. And then we're going to have some accessory glands. These are going to be called the salivary glands, the pancreas, liver, and gallbladder. And by any means, don't consider them an accessory. You can't live without some of these, such as the liver and the pancreas. But you could maybe live without your gallbladder. That is very common. All right, so let's start off with the oral cavity. The oral cavity, which is your mouth, it contains the roof of your mouth, which is known as your palate. The palate is divided into a hard palate and into a soft palate. The hard palate is made up of bone, predominantly your maxillary bone and a palatine bone. As you move your way posterior, you're going to see your soft palate. Your soft palate is predominantly muscle. When you say ah and you open up your mouth, you see this little U-shaped structure right there that is part of the soft palate. It's called the uvula. And your palate, when he sticks a tongue depressor in your mouth and he pushes your tongue and he says, he'll be looking for both of these palatal arches to elevate at the same time. Now, the big job of the palate is to prevent entry of food into your nasal cavity. Okay, so functions of the mouth, we do mechanical digestion. That's going to be done with chewing. We do chemical digestion. Actually, in saliva, there are some enzymes. So in saliva, there are some enzymes that will break down some carbohydrates and lipids in the oral cavity. We will see most of our enzymes come from our pancreas and enzymatic digestion occurring in your small intestines. The mechanical digestion, this was chewing. A fancy word for chewing is mastication. We moisten and we prepare our food for swallowing, so we kind of make it come to our tongue and our teeth, basically put food into what's called a bolus. And a bolus is basically a round-like structure. Our teeth, let's go ahead and just go straight to this picture right here. Our teeth right here, they are going to contain the crown, which is above the gingiva, above your gum line. The root will extend below your gum line. And then you have many layers. Our outermost layer is our enamel. And do you know enamel is the hardest substance in the body? And you're like, wait a minute, wouldn't enamel and bone be the same thing? Well, enamel and bone are both made of calcium and phosphorus. They call those hydroxyapatites, which makes it very, very strong. But the one difference between enamel and bone is bone has collagen in it, and collagen has a little bit of flexibility to it. Your teeth are not flexible. So enamel lacks the collagen and therefore making it the hardest substance in the body. Pretty cool, huh? Dentin is also a proteinaceous type of structure. It also is a supportive like a structure that supports the enamel below it. In the middle of the tooth here, we have what's called your pulp cavity. And your pulp cavity delivers the nutrients via blood vessels and nerves. And so when you get a root canal, you basically plug up this pulp cavity. Now, with looking at our teeth here, you have your back teeth, which we know as our molars. As you move forward, you have your premolars, your canines, and then your incisors, which would be in the front there. All right, tooth decay can occur, so you can get bacteria that will get trapped. Usually it gets trapped sort of right in this area between where the actual enamel reaches the gum line, and that's why it's very important for you to floss your teeth. I'm sure your dentist always reminds you of that. But bacteria gets trapped in there and you get this sort of plaquing that occurs. You can actually see this plaquing start to occur on an x-ray. The acid erodes the enamel and basically it causes you to have a cavity. So you basically, you can get a filling, which is when you have enamel that's been sort of eroded away, they can put, I'm not sure the substance, but they can put sort of like a cap in there. Inflammation of the gum line with bacteria trapped in here. This is gingivitis, which can lead to periodontitis, which can be an inflammation or an inflammatory event around all the structures of the tooth there too as well. All right, you do have these salivary glands, and you have 3 of them. These all contribute to the production of saliva. So the parotid gland is located near your ear, just anterior to that. The other ones kind of make sense. Sublingual, lingual means tongue. This one sits underneath the tongue. Submandibular, this one sits underneath the mandible. Now, what is the purpose of saliva? The purpose of saliva is to moisten food. The mucus in there will bind to food, and then there is some enzymes in your saliva. Salivary amylase being the more prominent one. Okay, Looking at our tongue, I'm just going to go right to this image right here. Looking at our tongue here, our tongue is important in speech and it's important in food manipulation. Your tongue is what's going to form that bolus of food, which is basically this sort of round-like mass that makes it easier for swallowing and pushing it into the throat, which is known as your pharynx there. And other things that the tongue has is taste buds. Some taste buds are there for grip, but some are there for taste. The term for taste is gustatory or gustation. That's spelled with a G there. I'm going to write that down for you. So gustation is the term for taste. And taste helps us monitor food quality, bitter, sweet, sour, all those different parts to taste. Now, the pharynx is a fancy word for your throat. And if you look in other books, you would have up here would be your nasopharynx, right here would be your oropharynx, and right here would be your laryngopharynx. Your pharynx is basically this open space behind your nose and your mouth here. And this will basically be a turning point for air and food. If you're air, you'll go forward into the respiratory tract, down the trachea. Your epiglottis will cover over that trachea, preventing food from going in there. But here we're talking about food, so here we're going to go posterior into the esophagus. So you can see this bolus of food there moving back towards the posterior. And everything that allows the food to travel here is reflexive. So there is special reflexes that allow your food to move from one area to the next. So now we're going to talk about the esophagus, which is after the pharynx. Your esophagus is a muscular tube. It's skeletal at the top, but then it's predominantly smooth muscle, and it transports food through your thoracic cavity from your pharynx to your stomach. Remember talking about the layers of your GI tract, and the third layer going from innermost to outermost was the muscularis layer, and I had mentioned a term called peristalsis. These are sort of rhythmic waves that allow of smooth muscle contraction that allow you to push the food down. You get these contractions that occur over the bolus of food, and it's hard to see from this view. It's actually like a twisting like action, and that allows you to push the food down to where it needs to go. All right, so from the esophagus, we will make our way into the stomach. But before we enter into the stomach, there is a sphincter. This is called the gastroesophageal sphincter. But we may have heard of something called GERD. GERD stands for gastroesophageal reflux disease. And if there is a problem with that sphincter, the stomach is very acidic. It has a pH of about 1 to 3. And so if there's a problem with the sphincter, we can have acidic-like contents come up into the esophagus. We commonly know this on a day-to-day basis as heartburn, but the more scientific term is for gastric esophageal reflux disease. And there could be a lot of different things that could lead to problems with that sphincter. So now we enter into the stomach, and the stomach is a J-shaped organ. I'm going to go right to this picture right here. It's a J-shaped organ. You can see the esophagus leading into the stomach. Right here, there's a sphincter. It's called a pyloric sphincter. And over here would be your small intestine. So you can see this sort of J-shaped organ. It gets kind of dome up front, and then it gets narrow towards the bottom there. And it's got bands of muscles, okay, at each end. Okay, so we have the pyloric sphincter up here. And right here between the stomach and the esophagus, we had the I'm going to write it out, esophageal, sphincter. Okay, so we had the gastroesophageal sphincter and then the pyloric sphincter. And that's going to regulate food going from the first one going from the esophagus into the stomach, and the next one going from the stomach into the small intestines there. You can see we also have 3 layers. Normally, your GI tract in the muscularis layer has only 2 layers, but the stomach, because of the amount of activity of churning that it needs to do, it needs to basically flip the food, churn it into this soupy-like mixture known as chyme. All right, so it needs a lot of muscle to do that. All right, so it's going to basically mix the food, liquefy the food, and that liquefied food form is called chyme. You will see that in your notes there. Now, in the stomach, we do begin chemical digestion of proteins. So we do start chemical digestion of proteins, and we're right here. That is done by an enzyme known as pepsin. One thing to remember that the stomach is very acidic. It has a pH of 1 to 3. Okay, so that prevents bacteria. It also helps us break down proteins, by activating this pH level, actually activates that enzyme right there. There's also another thing that's secreted in this area. It's called intrinsic factor. And intrinsic factor is necessary for the absorption of vitamin B12. So it clings to vitamin B12, and that B12 is actually absorbed later on in the small intestines. Okay, so continuing with the stomach here. Oh, I forgot one more thing. I mentioned that the pH is very low. It's a pH of 1 to 3, and it's hydrochloric acid that's secreted by some cells there called parietal cells there that create that pH of 1 to 3. Okay, so moving on with the stomach there. The stomach itself is protected by that acidic-like environment. It has a very, very thick layer of mucus. We release this gastric juice with food entering the stomach. So this gastric juice is very, very acidic. So it has a low pH. It has a low pH, but it's only released when we have food that enters into the stomach. So the food products actually absorb and dilute some of that gastric juice, and your stomach lining is actually replaced every 3 to 4 days. So if you think about people who are on cancer-like drugs, and cancer drugs, they attack rapidly dividing cells. So people that have cancer, whether it's lung cancer or it's breast cancer or whatever, they may have problems with their stomach because usually that chemotherapy is attacking rapidly dividing cells. It actually attacks their stomach cells too as well. So you find that they have a lot of digestive issues. All right, so moving on into the small intestines, there was the pyloric sphincter, which was right here in the stomach, the pyloric sphincter, and that had regulated food going into the small intestines. The small intestines is divided into 3 parts, the first one being the duodenum, the second part being the jejunum, and the third part being the ileum being the last part. So you can see the color that's divided in here. Duodenum is where most of our chemical digestion occurs, so where you have a lot of enzymatic type of reactions in there. The jejunum is where we do a lot of our absorption. The ileum, you actually can live without your ileum. You can have what's called an ileostomy bag, which is basically when part of your ileum's been removed, maybe to some disease process like Crohn's disease, and that ileum's been removed, and also the colon would be removed too as well, but you can have what's called an ileostomy bag. All right, so looking at the connection of the small intestines, okay, so here is specifically the duodenum. I had mentioned that the duodenum is where you have your chemical digestion. And when I say chemical digestion, I'm talking about having enzymes break down your food product. Now, where do we get these enzymes? So enzymes break down like carbohydrates, they break down proteins. They get their enzymes from the pancreas. And so you can see the pancreas is connected to the duodenum via a series of tubes. Now our liver makes bile, our gallbladder stores it. Bile is needed for the breakup of fats. It's called emulsifications of fats. So your duodenum is like really where all the action is happening, that chemical digestion. And then the jejunum, which is the next part, is really where we do most of the absorption. So we get all these enzymes from our pancreas. Our pancreas will also give us some bicarbonate ion, which will also neutralize. Remember, it's very acidic chyme. Okay, coming into here. Our duodenum's not built like the stomach with that thick layer of mucus to handle this. So I said hydrochloric acid right there. Bicarbonate ion, which is very alkaline, is dumped into that duodenum right there to neutralize that acidic chyme. So got a lot of important stuff there. So we've got enzymes, digestive enzymes coming from the pancreas. We've got bile coming from the liver and gallbladder. And we've got bicarbonate ion also coming from the pancreas too as well. Okay, so that was just what we had talked about previously. This is just showing you guys chemical digestion. So we've already mentioned polysaccharides get broken down into monosaccharides. So the enzymes would facilitate that. The enzyme that facilitates the breakdown of carbohydrates is called amylase. It comes from your pancreas. Okay, we also have an amylase that's secreted from our saliva too as well. Here we have a protein, and a protein is broken down into amino acids. Now there's kind of an intermediate here. There's 2 places where you can break down proteins. In the stomach, we have pepsin, which starts protein breakdown. So it initiates, proteins can be really big. So it initiates protein breakdown. I'm just going to do an arrow with that. And then what will happen is proteases from the pancreas, these will further break it down into amino acids. So further break down that protein, into amino acid, which is the smallest form there. We can see fat digestion. So we have what's called lipase. That's pretty easy to break down lipids. Also bile too as well. Bile will basically, these are bile salts, which are a component of bile. Fat globules will usually stick together. Bile salts will cause what's called emulsification. This is all in your notes. Emulsify or emulsification of fats. And this basically says don't stick together. If they don't stick together, then lipase can do a better job of breaking down these fats. So lipase is the enzyme that breaks down the fats. When I say breaks down the fats, most of our fats that we get from our diet are in the form of triglycerides, which is a glycerol molecule and 3 fatty acid chains. And lipase breaks these bonds between there. These are all individual triglycerides. Bile salts basically separate all the triglycerides, so lipase can come in and do a better job there. Okay, with the small intestines here, we are absorbing all these nutrients. That pretty much happens predominantly in the jejunum. And just looking at this image right here, if you look at the small intestines, you have these things called pleated lining, or these folds right here. These folds right here. Sometimes they call them circular folds, and in that you have what's called villi. And in the villi, all of these individual cells are made up of microvilli. And so I don't know if you've ever heard of your small intestines being as long as a football field. If you flatten out all the folds, and you flatten out all these little villi right here, and you flatten out all the microvilli, then you've got your football field. And so what these folds are doing, all of these folds are ultimately increasing the surface area for absorption. And so they're basically allowing more area for absorption over less landscape, over less real estate, basically. All right, so in the villus, you guys can see, I'm going to go right back to this. You guys can see we have a network of capillaries, because our food products will be absorbed into those capillaries right there, and they will carry away all of those products of protein and carbohydrate digestion. The lacteal is actually a specialized lymphatic vessel. Fats are too big, so they're carried away in lacteals, but they will eventually make their way into your venous system. And so when these fats are traveling in your lacteals, fats don't do well in water. And in your lymphatic vessels, it's lymph, which is pretty much like plasma. It's mostly water. And so they're packaged with some structures called chylomicrons. And so they're packaged with chylomicrons that attach to the fats, and they're basically like fat taxi cabs. They're proteins that are taxi cabs to transport fats, because fats don't travel well in water. And your body is mostly water. Your blood is mostly water. Okay, so that pancreas, we've been mentioning that pancreas provides us, let's go right to this image right here. You can see your pancreas provides us with digestive enzymes, okay? Those enzymes include amylase, which breaks down your carbohydrates, proteases, which breaks down your proteins, lipase, which breaks down your lipids, okay? There's also bicarbonate ion too as well, so I had mentioned that before. Bicarbonate ion, HCO3, is dumped into the small intestines. Remember, your stomach has a pH of 1 to 3. So that is very acidic. The soupy-like mixture of food in here is called chyme. And when that acidic-like chyme enters into the small intestines, into the duodenum's not built to deal with that. So the pancreas will dump this bicarbonate ion, and that will neutralize it. Okay, so not only is the pancreas going to be giving us our pancreatic enzymes, digestive enzymes right here, it's also going to be giving us that bicarbonate ion. Now, you can see the close relationship here of the liver too as well. So the liver gives us bile. This is one of its job. The gallbladder stores bile. And you can see via tubular connection that bile can be dumped into the small intestines here. And it does a term, emulsification or emulsify of fats. And it basically says, makes your fats, your triglycerides not stick together. Now, your liver does a lot of other important things. So looking here, it has what's called the hepatic portal system. All right, and let's go right to this image right here. You have a ton of this venous blood supply coming from your intestines. And all this venous blood supply is going to contain all the nutrients from the food that you just ate. And all of it's heading back to the liver. The liver is responsible for processing all of these nutrients. Not only does it produce bile, but it stores your glucose, it stores your fats, it stores your proteins, and it detoxifies. Okay? It detoxifies poisonous substances. So when you are taking in large amounts of alcoholism, the liver is usually the first organ to be shot. And what happens is the cells in your liver, they're called hepatocytes, they die. And when they die, they get replaced with fat or scar tissue. And they commonly call this a fatty liver when the liver is not functioning properly. All right, so looking at disorders, like I said, cirrhosis, this is a fatty liver. Hepatitis is inflammation of the liver. We can get hepatitis from a lot of different places. Hepatitis A, B, and C, these tend to be bloodborne, okay? D, E, and G, these tend to be from contaminated water or food or contaminated water sources usually. And basically when the liver gets inflamed, it's just not functioning properly. It's not filtering bilirubin, which is a byproduct of your hemoglobin. And so bilirubin is a precursor to bile. And basically if you can't flush it out of your system, if it can't go through your liver, it starts to deposit in the periphery, like in your nails, in your eyes, in your skin. And you get this yellow coloring because bile is a yellow coloring, bilirubin. That is the pigment of bile. Okay, bilirubin is the pigment of bile. And this bilirubin here, it causes the yellowing of the skin is called jaundice. It's called jaundice. Our gallbladder, which is a little sac that hangs on the underside of the liver, it stores and concentrates bile. Disorders of it is gallstones, and it's very commonly removed. So some people are just more susceptible to these. It can be diet related, or it can be genetic related. And when people have gallbladder attacks, they commonly have it removed very quickly, and their liver would just take over the bile process. All right, so moving on to your large intestines, I'm just going to go to this area right here. Your large intestines is basically not necessary for life, but it's basically taking all indigestible material and it's moving it towards the rectum anus to get it out of the body. So it absorbs some water. It stores and eliminates feces. Feces are undigestible material. It can produce a couple vitamins such as vitamin B and vitamin K, but really it's not necessary for life. So the first part of the large intestines is called the cecum. Then this part right here is called the ascending colon, then the transverse colon, descending colon. This little loop-de-loop right here is called the sigmoid colon. We then end up in the rectum, and then we end up out as the anus. There is sphincters that can control the opening and closing of that anus. And they're showing right here a big venous supply right here, and that's where hemorrhoids can be derived from. We do have an accessory structure, the appendix right here. It's not really used by us anymore. It's a vestigial structure, so it was used as when we were previous man for different types of food that we would have eaten. Okay, so how do we move food through here? So you get peristaltic-like contractions. They're a little bit slower. Feces is pushed through all these areas. You can actually, when you listen with a stethoscope when someone's doing a physical exam, you can hear bubbling, and that is movement of food through parts of these areas. You have sphincters at the end, okay? You have an internal and actually an external, okay? Right now they're just showing the external. That would be under our control, voluntary control. When we have to go number 2 and there's not a bathroom around, we hold it in. That would be this one. The internal one, which is right here, they don't have it labeled, but the internal one is not in our control and just automatically relaxes when the presence of feces come into this area. Now, there is some disorders of this diarrhea. Basically, not enough water is absorbed, and so you have a fluid-like feces. Constipation, material just sits here. Feces just sit too long, and too much water is absorbed. You can get little pouching that can occur. This is called diverticulosis, but they can become infected and inflamed, and that can lead to diverticulitis. You can have cancer in here. There's a procedure called a colonoscopy, and they would be going in looking for maybe a polyp, a polyp can turn cancerous. And so you can either go up through here, would be a colonoscopy, and you can also come from the oral cavity, and that would be an endoscopy. That's usually not for this part right here, but usually a colonoscopy would be for the large intestines here. Endoscopy, if you want to do small intestines, that would go through the mouth. All right, so we went through that there. Okay, so enzymes must be in the right place at the right time. You only release enzymes when food is produced. Nerves and hormones will regulate the release of these digestive enzymes. Hormones can, sometimes hormones are more used. You can see processes that are quick would be a nervous system thing. Processes that take more time can be a hormone thing. So it's basically a dance. It's a dance between hormones and enzymes that both work together. Salivation is controlled by the nervous system. The release of gastric juice is controlled by the nervous system. The hormone gastrin, you can spend up to 4 hours in the stomach. You can spend up to 4 hours in the stomach. And so that's why they talk about eating slow. You can see here just talking about different things, and which is the nervous system and which is the hormone system right there. Enzymes from the small intestines and the pancreas and bile right there. These are neural reflexes, so it's a little bit quicker. Hormones too as well can be secreted from the small intestines. So we have a dance of both of these here. Food provides us with the fuel and building blocks. When we say building blocks, we're talking about glucose, we're talking about amino acids, we're talking about parts of nucleic acids, we're talking about lipids for energy. And so these are needed in order for our body to make ATP or to carry out the chemical reactions it needs to do that. Our digestive system breaks down these carbohydrates, fats, and nucleic acids into the smaller subunits, and then we absorb it across our gut wall, and usually our liver will rebuild them as necessary. Some are essential and some are not. Some things the body can produce. Looking at lipids, this is something we touch based in lab. These includes fats, oils, and cholesterol. Cholesterol is part of the family of steroids, okay? We have saturated fats and we have unsaturated fats. Saturated fats are fats that are solid at room temperature. This is like a butter. Okay, if you turn unsaturated fats is oils. If you turn unsaturated fats, which are liquid at room temperature, into a saturated fat, into a solid, that would be a trans fat. So those are not good because they're chemically altered. Saturated fats are like butter. Unsaturated fats are liquids like our oils. Cod liver oil, different kinds of liquid oils there. Flaxseed oil. And so elevated levels of cholesterol can be an indicator, can lead to heart disease. Carbohydrates, we have complex carbohydrates. These are going to be our polysaccharides, as they contain a lot of vitamins and minerals when we use them. So usually our green leafy vegetables would contain in these complex carbohydrates. Our carbohydrates are broken down, polysaccharides are broken down into glucose. And glucose is going to be our quickest source to provide us with energy, meaning they're going to be our quickest source for our cells to go through cellular respiration and make ATP. Fiber is a type of polysaccharide. It does not broken down in the body, but when it does make its way into the large intestines, it provides us some bulking-like agents, okay? And it also helps reduce LDLs, okay, which is low-density lipoproteins. Those transport cholesterol to our blood, whereas you may have heard of HDL. HDLs transport cholesterol to our liver, and we excrete it out of the body. We want low LDLs, and we want high HDLs. All right. We have some other things that we take in. We talk about amino acids. Amino acids are the building blocks of proteins. We have 20 amino acids that we get. 9 of the body must be obtained, okay, by the diet. So we make some of them, but we don't make the other ones. And so complete proteins, these are mostly like eggs, meat, milk. Incomplete proteins, these would be like vegetarians would be getting these. These are usually lacking essential amino. You need to have a mixture, beans, legumes. So you need to make sure if you're a vegetarian and you're probably eating more incomplete proteins that you eat the right ones so you have a mix of the right amino acids to obtain. Vitamins, these are usually facilitators to help our body do things. So they can serve as enzymes or coenzymes. So vitamin B is probably the most common one. We had NAD and FAD in cellular respirations. Those were B vitamins. There is fat soluble or lipid soluble vitamins, which is vitamins A, D, E, and K. Some of these are antioxidants. Vitamins A, C, and E, those are antioxidants, and they neutralize free radicals. What is a free radical? That's usually something in the body that's running around with an unpaired electron and it likes stealing electrons from other things, making them have unpaired electrons. So vitamins A, C, and E, and selenium, these are considered antioxidants, and they neutralize free radicals. Minerals, a lot of these include things like sodium, potassium, which you know are important for your action potentials, your nerve impulses. We have iodine, which is used for thyroid hormone. We have iron, which is used to bind oxygen and hemoglobin. Calcium, which is used for bone metabolism. A lot of different minerals out there that we use in small amounts, but they are involved with a lot of processes in the body. Water does a lot of functions. We don't realize how important water is. It transports materials, lubricates, cushions, temperature regulations, and provides a medium for chemical reactions. So when we talk about like hydrolysis reactions or dehydration reactions. Your BMR, this is calculated by certain ways, and so there is whole chemical equations for calculating your BMR, but this is basically the minimal amount of energy needed to keep an awake, resting person alive. So it represents 60 to 75% of the body's needs. Males usually have higher BMRs. They have more muscle mass. They have more bone density. And as you age, your muscle mass and your metabolic rate do decline. So you can see here, BMR is reflective of the number of calories you use in your physical activity. So it's like working out and how much you consume to maintain a stable weight. This is just talking a little bit about exercise and how beneficial it is here for the reduction of heart disease. Weight-bearing exercise is good for your bones and bone density. And so other things psychological include stress and the risk of chronic diseases too as well. There is disorders with eating disorders here. Obesity, anorexia nervosa is a form of self-starvation. Bulimia is binge eating followed by vomiting afterwards. So many different things can contribute to these eating disorders. All right, and that is it.